Hi guys. Previously we were learning about 7.3 similar triangles, and we're going to continue on with that today. So we saw angle-angle similarity, and we learned that you need two pairs of congruent angles to say that the whole shape is similar to another shape. We checked some, we used different theorems, like for example right here we have vertical angles theorem. We also have alternate interior angles theorem, which helped us out in knowing that these two triangles were similar. We also saw side-side-side similarity and side-angle side similarity, where we checked proportions based on smallest side, biggest side, medium side, and made sure they made sense. We saw properties of similarity, reflexive, symmetric, transitive, and then we did some solving. Now, the solving with algebra, we can't really match up smallest, biggest, medium, so we match up based on the congruent angles and things that we know based on a similarity statement. And then we saw one example of indirect measurement, a story type problem, and now we are going to look at the second example. I would encourage you to pause the video and try this before I go through it. All right, hopefully you pause the video. On her trip along the East Coast, Jenny stops to look at the tallest lighthouse in the U.S., located at Cape Hatteras, North Carolina. At that particular time of day, Jenny measures her shadow to be 1 foot 6 inches in length, and the length of the shadow of the lighthouse to be 53 feet 6 inches. Jenny knows that her height is 5 feet 6 inches. What is the height of the Cape Hatteras lighthouse to the nearest foot? So, notice something tricky here. 5 feet 6 inches is not 5.6. 6 inches is actually half of a foot. So this would be 5.5, and 1 foot 6 inches is 1.5, and 53 feet 6 inches is 53.5. So notice, don't put 0.6 there. Hopefully you didn't. Now, I'm going to compare my height of my objects, so 5.5 over x, so the height of the person, the height of Jeannie is 5.5 over the height of the lighthouse equals the shadow of her, 1.5, over the shadow of the lighthouse. So now if I cross multiply, remember you can actually set this up a bunch of different correct ways. This is just one way. I get 1.5x equals 294.25. When I divide, I get that x is equal to 196.16, repeating, but it does want us to round to the nearest foot. So the lighthouse is about 196 feet tall. If you pause the video, you can actually look up this lighthouse and see its height. It is truly very, very close to 196 feet. So we have a quick concept summary here. It's about our different postulates, our angle-angle similarity postulate, our side-side similarity theorem, our side-angle side similarity theorem, and what you need. Either two pairs of congruent angles, 3 pairs of proportional sides, or 1 pair of angle and 2 surrounding pairs of proportional sides. If you have just those things, we know that our triangles are similar. We do have a couple proofs to follow, though. There will be proofs on your Chapter 4 test, so it's pretty important that you really pay attention to these, try to understand where everything's coming from, and know what you're doing. So, always, never, ever, ever miss your first statement. It is what you are given. Measure of angle 1 is equal to the measure of angle 2. Angle E and angle R are right angles. This is always the reason given. Never miss your given first statement. So, if something is said to be equal, we can't really do much with that. We want to switch this to congruent. So we can say angle 1 is congruent to angle 2. I know it doesn't really seem that different, but it is. And anytime we switch from equality to congruence or congruence to equality, this is called the definition of congruent angles. So now I know angle 1 and angle 2 are congruent. That's great. Now I'm going to say that angle E is congruent to angle R. This is because right angles, you can shorten it with a little symbol, are congruent. Okay, we know all right angles are 90 degrees, but we do have to state that. We can't just assume it. Now that we have two pairs of congruent angles, we can actually use angle-angle similarity to say that triangle WEA is similar to triangle ARQ. That is our proof statement. You just rewrite that. And this is by angle-angle similarity. And we're good to go. The next one, I think this one's actually a little easier. We start with our given. Segment AB is parallel to segment ED. This is given. So I'm going to mark that. I'm also going to extend these. And a transversal, because I can. I'm going to say that angle B is congruent to angle D. They are. Because of alternate interior angles. Then I'm going to say that these two pairs of angles are congruent. Angle ACB is congruent to angle DCE. Hopefully you're getting used to this now. We have vertical angles theorem. And then, because we have two pairs of congruent angles, we can use our proof statement. And this is once again by angle-angle similarity. And we're good to go. We've proven that our triangles are similar. Okay? Have a great rest of your day. If you have not finished your 7.1 and 7.2 Delta Math, definitely work on that. I also have opened up the 7.3 and 7.4 Delta Math. You can do some of those problems, not quite all though, because we haven't done 7.4 yet. Anyway, have a great day.